Later we all know that this lepton number is not conserved. Berbeza dengan baryon number, because baryon number is very much closely related with charge from the Gell-Mann-Nishijima formula. Okay, so we all know that charge conservation is, conserved by all kind of interaction. But this lepton number has no so-called physical basis. It is based only on the idea that they run in families. So, why is neutrino mixing or changing of flavor called oscillation? This is because these neutrinos, they don't interact and they propagate through space. First, it is a quantum mechanical phenomenon. Whereby a neutrino created, by some reaction, created with a specific lepton flavor, or lepton family, say electron type, muon type, or tau type, later can be measured to have a different flavor. Later change into a different this is just like the kaon, where it changes the particle, a mixture of a long and short component. So after a long traveling time, the kaon only have the long component, short component already decayed. But this for neutrino, this is very different. It has no long or short component. Anyway, this was first predicted by Bruno Pontecorvo in 1957. And it has been observed by a multitude of experiments in different contexts. And it also shows you the equation that describes this. It means that all this while, all the textbooks saying that neutrino is massless is wrong. So it seems that only photon has no mass. But anything else has mass. So photon is, even though it's a boson and it is the gauge boson for electromagnetic field, photon has a special, there is something special about light. You see with light, you use electromagnetic wave, which is light also, for everyday communication, handphone, internet, semua pakai photon. Then you go into the photonic, and then there are many things, all using light. So light is something special, God given. A great deal of evidence for neutrino oscillation has been collected over the years, and so for today, and this neutrino measurement were done first, the solar neutrino, and then you also study neutrino coming from reactors, nuclear reactors, and then there are specific neutrino source that are studied for some So let's just write down what Pontecorvo first suggested. So he suggested that he proposed that neutrino and antineutrino transition may occur in analogy with kaon mixing. So this formed the conceptual foundation for the quantitative theory of neutrino flavor oscillation, developed by Maki, Nakagawa, Sakata in 1962. Develop this idea further. And then also by Pontecorvo in 1967. Bila dia tengok orang lain guna idea dia, dia pun get excited. Mula-mula mungkin idea dia tak laku. Mungkin goreng pisang dia mula-mula tak laku. Bila tengok orang lain jual goreng pisang laku pula, wah, dia kata aku punya goreng pisang ni kena modify. Tahu cheese lah. Itu yang Pontecorvo ni tahu cheese lah dia punya goreng pisang dia. In 1967 dia bangun balik. The nice thing was, in 1968 orang yang mengukur mengukur neutrino di Gran Sasso dan sebagainya di Geneva dan lain-lain tempat, ada masalah neutrino deficit. So 1968 neutrino deficit, kekurangan. The neutrino deficit problem was discovered, meaning detector only measured 1/3 of solar neutrino, because detector is only for neutrino electron detection. Yang muon dengan tau dia tak sensitif, so tak dia itulah. Now, the problem with this neutrino oscillation not so simple. Not just neutrino electron menjadi neutrino muon dan berubah lagi menjadi neutrino tau. But it arises from mixture, not only from the flavor, maknanya flavor, tapi ada lagi satu, mass eigenstate pun dia kacau. So the three neutrino state that interact with the charged lepton in weak interaction are each a different superposition of three neutrino state of different mass. Okay. So The neutrinos that are created in weak process in their original flavor eigenstate propagate through space, and quantum mechanical phases of the three mesh state at once at slightly different rate due to the difference in the neutrino mesh. This results in a changing mixture of mesh state as the neutrino travel, but a different mixture of mesh states correspond to different mixtures of flavor state as well. So a neutrino born, say as an electron neutrino, will be some mixture of electron, muon and tau after traveling some distance. Since the quantum mechanical phase advance in a periodic fashion, after some distance the state will nearly return to the original mixture, and the neutrino will be again almost 100% electron neutrino. Ini yang pelik tentang neutrino oscillation. It will come back to its original, katakan asalnya dia ni orang Melayu. Dia pergi England jadi Mak Saleh sekejap, dia pergi Sweden jadi orang Swedish sekejap, tapi bila dia balik Malaysia dia jadi orang Melayu balik. Ini neutrino lah ni. Dia tak lupa, orang tak lupa daratan ya. Tak lupa daratan. So it always come back ya. Then the electron flavor content of the neutrino will then continue to oscillate as long as the quantum mechanical state maintain coherence. Since mass difference between neutrino flavor are small in comparison with long coherent length of the neutrino oscillation, this microscopic quantum effect become observable over macroscopic distance. And of course, because satu lagi ialah neutrino never interact with anything, so you can always look at this oscillation at long distance. And also there is another thing, you cannot measure it in the lab. So there is another thing, because nombor satu detector dia pun kena berapa puluh tan air yang mengandung klorin, and then you only detect some spark or something. So that's one thing. The other thing is neutrino won't interact with anything, so you need these detectors. So the form of this oscillation. So in its simplest form, so next number 2. In its simplest form, the oscillation can be expressed as unitary transformation. Relating the flavor and mass eigenbasis. Say neutrino alpha can be written as a summation of all possible neutrinos. Yeah. So this alpha, say an alpha neutrino can be written in terms of all the possible neutrinos, where I equal to electron, muon, tau. Now this, yang ini pula, yang that particular neutrino pula of the individual flavor can be written in terms of the U alpha I U alpha. So this is like a inverse, like the inverse. So new alpha is with the is a neutrino with definite neutrino with definite flavor. So alpha is electron, muon, or tau. Okay. Whereas the I is of definite mass. So this is the eigenstate of the definite mass. Neutrino with definite mass. Where Mi mass Mi, where I is 1, 2, 3. So when we consider considering the 3 neutrino, this so the matrix that describe this oscillation is you know you have you need to have okay, it's 3 by 3, yeah? Because there are 3 mass and 3 flavor. Okay. 3 mass and 3 flavor. There are some theory whereby it is 4 by 4. How come? Because there is a theory which says that you can have a false neutrino, which have not been seen, but called a sterile neutrino. It is a neutrino, but dia tak kacau pun flavor-flavor ni. And one of these ideas is that this sterile neutrino form this dark matter, katanya, wallahu a'lam. Sterile neutrino. So there is a false neutrino, but we don't know whether that's true or not. So, but you can theorize. So anyway, U is written as U electron 1, U electron 2, U electron 3, and then U mu 1, U mu 2, U mu 3. And U tau 1, U tau 2, U tau 3. Okay? And actually, it can be parameterized into a 4. So we don't need to write all of that. You can actually the and the nice thing is that the 3 of that can be written similarly to the saya dapat gambar the apa ni CKM looks like a CKM parameterization C12 C13 S12 C13 S13 E minus I delta. So this is a 3 by 3 matrix minus S12 C23 minus C12 S23 S13 E I delta C12 C23 minus S12 S23 S13 E I delta S23 C12 S23. Then you have S12, S23 minus C12, C23, S13, EI delta minus C12, S23 minus S12, C23, S13, EI delta. So here it is C23, C13. But there is, so here even though this look like CKM, here it is 1, 0, 0, there is another one, 0, EI alpha 1 divided by 2, 0, 0, 0, EI alpha 2 divided by 2. Now, the Cij is obviously the cos theta ij, and the Sij is the sin theta ij. The neutrino are Majorana particle. If neutrino is a Majorana particle, what does Majorana particle mean? If the neutrino is identical to its antineutrino. So this means that neutrino equal to antineutrino. If neutrino not equal to antineutrino, this is called direct particle. And actually, whether it is Majorana or direct, it is still unknown until now. And if it is 0, then this will become 111. If it is direct particle, katakan, then this will be 111. Because e to the power of 0 is 1. Anyway, if neutrinoless double beta decay occur, these factors will influence its rate. The phase factor delta is non-zero only if neutrino oscillation violate CP symmetry. So delta not zero if neutrino oscillation violate CP symmetry. So the delta is the CP symmetry violating phase. This is expected, people say, but not yet observed experimentally. If the experiment show this 3 by 3 matrix not to be unitary, unitary ni apa maknanya? If 3 by 3 PT apa ni? PT Portico Maki Nakagawa Sakata. If this 3 by 3 PMS is not unitary, this means that a sterile neutrino or some other new physics is required. The sterile neutrino itu yang kata mungkin 4x4 dah boleh, yang melibatkan satu sterile neutrino. In fact, if it is not unitary, you need to go beyond the standard model. Sebab cerita tentang sterile neutrino, tentang non-unitarity ni, because you know quantum mechanics semuanya what you call it transformation need to be unitary. So maknanya unitary kalau that so U must be equal to U transpose. Yeah. So this is unitary. If it is not, then but quantum. So this unitarity is the foundation of the quantum mechanics. Itu sebab remember that you can have you can write the dynamic of the Hamiltonian by writing that the Ht equal to U H at T0 U. So at time T U H U given at T0. So this is a dynamic. Knowing the Hamiltonian at time 0, you will know the time at T minus Pi dot x. Nu I at time 0. Okay. So ini C H bar semua equal to 1. So this EI is the energy of the mass eigenstate. T is the time from start of propagation. Pi is three-dimensional momentum. X is current position of particle relative to starting position. So and since the mass of neutrino is not that big, much smaller than electron. Nah, ini yang menjadi orang kata zero dulu. Tapi sekarang kita kata not necessarily zero. Yeah. Since it oscillates, the mass must not be zero. So in relativistic limit, because mass dia tak berat, maka dia pun kelajuan dia hampir laju cahaya. Of course, yeah. So EI, which is Pi square plus Mi square. Sebetulnya ada PIC square Mi square C to the power 4, tapi C dengan H bar kita dah jadikannya satu. So this is about Pi plus Mi square divided by 2Pi. So that's about E plus Mi square divided by 2E, where E is the total energy of particle. Now, this T, the time, proportional to distance travel. So this equation here, star equation, becomes, instead of T we use L. After all, they are proportional. E I M I square L divided by 2E mu I 0, meaning at 0 length lah, meaning at starting. Now this is important here.